Next, we'll work for practice 12.3. Suppose that 0.48 grams of water at 25 degrees C condenses on the surface of a 55-gram block of aluminum that's initially 25 degrees C. If the heat released during condensation goes only toward heating the metal, what's the final temperature in degrees C of the metal block? The specific heat capacity is given of aluminum at 0.903 joules per gram degrees C. So we know that Q for the water is equal to negative Q for the aluminum. And we learned last semester that we could set two MC delta T equations together and solve for something like the final temperature of one of those things. But when we're considering condensation and vaporization, we're not being governed by the MC sub S delta T equation. What we're governed by is the number of moles times the vapor pressure, or the delta H of vaporization, right? And so we can still say the Q of the water is equal to the negative Q for the aluminum, but we need to calculate the Q for the water from the delta H of vaporization, or rather the delta H of condensation. So remember, the delta H of vaporization is equal to negative delta H for condensation. Those are equal and opposite processes. And we can also say that the negative delta H for vaporization is equal to positive delta H of condensation. So the delta H for condensation, being opposite of the delta H of vaporization, is going to be negative 44.0 kilojoules per mole. So the Q for the water is given by 0.48 grams of water times, we're going to divide by the molar mass, 18.02 grams per mole for water, and the delta H for condensation is negative 44.0 kilojoules per mole. And that gives us negative 1.172 kilojoules. All right, and we need to convert that to joules because our C sub S for the aluminum is 0.903 joules per gram degrees C. So that is equal to negative 1172 joules. Okay, and that's the delta H, or rather that's the Q for the water. So we're going to put that here. So we know that negative Q for the water is equal to Q for the aluminum. And so we can replace the Q for the aluminum with M C sub S for the aluminum, delta T for the aluminum. Because the aluminum is changing temperature, so we can use the M C sub S delta T equation. Okay? So we can solve for delta T by dividing the negative Q for the water by M C sub S. So delta T is equal to negative Q for the water divided by M for the aluminum, C sub S for the aluminum. So that's the mass times the C sub S for the aluminum, which is equal to negative 1172 joules divided by 55 grams for the aluminum times 0.903 joules per gram per degree C. And so that's equal to 23.599 degrees C. So that's our delta T. Remember, delta T is equal to T sub F minus T sub I. All right, and therefore T sub F is equal to delta T plus T sub I. So that's equal to 23.599 degrees C plus 25 degrees C. So that's equal to 49 degrees C. So our final temperature is 49 degrees C.